part. Okay, we complete this piezoelectricity and ferroelectricity. These two are also important, but we don't know. Okay, piezoelectricity. Okay, piezoelectricity. So what is this piezoelectricity means? Suppose if you have a dielectric material, okay, if you have a dielectric material, so that material, if you apply some electric field or some voltage, or so that electric field, that material, what that will do, that will convert the mechanical energy into electrical energy. Okay, so what is the physioelectric means? Some materials behave, or some materials, some dielectric materials convert the mechanical energy into electrical energy, or vice versa. Okay, that means if you apply some electric field, if you apply some electric field, that will convert into mechanical energy, or if you apply some mechanical energy, that will convert into some electrical energy. That means electric field or current or something like that. Okay, so this is the some dielectric materials behave like this. Okay, so whatever material exhibit this property, that that materials we are calling piezoelectric crystal, and the phenomena we are calling piezoelectricity. So what is the piezoelectricity means? Some of the crystal exhibit, or some of the crystal shows the, or some of the crystals having ability to convert mechanical energy into electrical energy, or electrical energy into mechanical energy. This phenomena we are calling piezoelectricity. These crystals we are calling piezoelectric crystals. Okay. Example quartz. Okay, example quartz. This is also some glass material. Okay, quartz glass. Okay. So is it clear the definition?
Yes, sir.
Very simple. Some of the dielectric material convert the mechanical energy into electrical energy, or you can say electrical energy reverse also possible, electrical energy into mechanical energy. These phenomena we are calling piezoelectricity. Okay, that we will see some examples. We'll consider some examples and we will see. Okay, so here you take a material. Okay, you take a material here. Here dielectric material you are taking. So when you take these two materials, when you apply some stress, suppose you have a material here, minus and plus. So when you apply mechanical energy, that means you compress, or when you compress, or you can say when you expand, or you pull the material, or you compress the material. Okay, that means you are applying some mechanical force. Okay, mechanical force you are applying, stress, either stress or strain. Okay, you are uh, compressing, or you are means elongation. Okay, that is also you can applying stress strain you are applying. Because of this stress strain, these charges are moving. Okay, how we are getting electric current or electric field? That means when you applied some mechanical stress, these charges are moving within the atom. These charges are moving within the atom. So when you when you expand also, these charges are moving within the atom. Because of this movement of charges, some current is producing in a material. That is what when you apply mechanical stress, you are seeing some electrical field or some current. Okay, is it clear of how the dielectric material is converting mechanical energy into electric field or electrical energy? That means why? So here you are taking a one material, dielectric material, that is already dielectric material means you, it is plus minus, already polarization you take it. Okay, otherwise you can apply also. So when you applied some pressure or some force, you are compressing. First case is you are compressing the material, and second case you are expanding the material, you are pulling that. Like a, if you have a sponge, right? Whiteboard will clean that sponge. You can compress and you can expand. Okay, like that. When you compress this material, what happens? These charges will move to and fro. These charges will move. Because of this movement of the charges, we'll get some current. Okay, when you expand also, these charges will move. Okay, because of this movement of the charges, we'll get some current in a material, in a dielectric material. That's what this will, when you applied mechanical force or mechanical energy, we are observing some electrical energy. Okay, is it clear, this example?
Yes, sir.
Do you understand, right? If you have doubts, you can ask. Okay, this is small examples you can see here. And next one, ferroelectricity. Okay, this is ferroelectricity. So what is the ferroelectricity means? Suppose you have a atom here. Okay, you have a atom here. When you applied some electric field, what is happening? Charges are inducing, right? Plus charges are inducing one surface, and other opposite surface negative charges are inducing, right? This is what dielectric materials behaves. When charges are induced, we are saying polarization is taking place or polarization is happening. Okay, polarization, this is what we are calling polarization in dielectric material. Okay, now suppose if you remove this electric field, so you make this electric field zero, then what should happen here? When you applied electric field, charges are separated. So when you remove this electric field, or when you make this electric field zero, then what should happen here? What should happen?
The charges should combine.
Yeah, charges should be restored. That means neutral atom should be formed, right? When you make E should be zero, when you make E equal to zero, or if you remove E electric field, the charges should be combined, then we will get the neutral atom. But what is happening? Some polarization is remaining in the material. Okay, this is not happening. This case is not happening. Actually, this should happen, but this is not happening. That kind of material, that kind of behavior, we are calling ferroelectricity. So even when you removed electric field, or when you make the electric field zero, still some charges are separating. Already they are remaining in a separation condition or separation mode. Okay, because of this one, we are observing some polarization. Okay, so this is what ferroelectricity means. When you make electric field zero, these charges should be overlapped, means combined. That means neutral atom should be formed. But this case is not happening. Still some charges are in the separation condition only. They are in the separation mode only. So because of this suppression of charges, we are observing some polarization. That is what that is what you can say spontaneous polarization. Spontaneous of polarization. So the here ferroelectric materials means ferroelectricity means some of the dielectric materials shows spontaneous polarization in the absence of electric field. In the absence of electric field, that means what? We are making electric field to zero, but this we are observing some, still some, we are observing some polarization. This polarization we are calling spontaneous polarization. So this one, whatever the materials behave this phenomena we are calling ferroelectricity. Ferroelectricity means some of the dielectric materials shows the spontaneous polarization in the absence of electric field. In the absence of electric field, this phenomena we are calling ferroelectricity. Okay, some examples are barium titanate and Ruchelli salt, and some other are there. Okay, these two are enough. Okay, BaTiO3 is Ruchelli salt formula. I will give chemical formula right now. I don't know, so I forget actually. So is it clear the definition?
Yes, sir.
So what we have studied, physioelectricity, electricity, and physioelectricity means mechanical energy into electrical energy, or electrical energy into mechanical energy. Electrical electrical energy. This is the physioelectricity. And ferroelectricity means, so these are closely terms are very close, so you may, there is a chance of confusing. So here they will show some spontaneous polarization. So spontaneous polarization, spontaneous polarization, spontaneous polarization, even electric field is zero or in the absence of electric field, in the absence of electric field. These are the two very very important properties of dielectric materials. Dielectric materials. Okay. Piezoelectricity means the phenomena of a dielectric material which converts the mechanical energy into electrical energy or electrical energy into mechanical energy. Ferroelectricity means the dielectric material, some of the dielectric material shows the spontaneous polarization or polarization even in the absence of electric field. Okay, these are the two differences. Okay, and next one, these ferroelectric materials exhibit the hysteresis behavior. Hysteresis behavior. This is hysteresis behavior. What is the hysteresis behavior? Just we'll see now. Okay. So hysteresis behavior means when we are getting polarization, generally when you applied some external electric field, right? That is the main applying electric field is the main property, main work we are doing. Okay, main work we are doing here. What is happening here? See this one. This is so you have a dielectric material and you are applying electric field. You are applying electric field. Depends on this electric field, you are observing some polarization in the material. Polarization in the material. So first you applied zero. We'll go to the origin. You are applied here zero electric field. That means no polarization. So you are slowly increasing the electric field. You are observing the some polarization. First you observe some electric field, then you can see some polarization. Okay, it's like that you are observing, you are increasing the polarization and it is reached saturation. Polarization reached saturation. That means after that here once you applied electric field, all charges are separated. All charges are separated like this. Okay, that means no charges are there uh, because you have given maximum electric field. With this maximum electric field, all charges are separated. All charges are separated in a atom. There is no more charges left in the atom. No more charges left in the atom. So this is what saturation polarization means. Okay. After saturation, what we are doing? You are removing the electric field. That means, or you can say, you are reducing the electric field. Once you reduce the electric field, polarization also reducing. Polarization also reducing, but it is not coming to zero. Still, this is having some polarization. So suppose this curve, if you return back to here, suppose here, if you go like this and can you hear me?
Yes,
Hello?
sir.
There is a small power cut. Sorry for the interruption. So suppose you are applying electric field where this is the origin. Okay, suppose we are when you applied electric field where atom is getting polarization, so here it is reached saturation. PS means saturation polarization. So if you remove this electric field or you reduce the electric field, if this is follow same curve, then it is okay. It is reversible condition or reversible process. But this is not happening. Okay, this is not happening. So when you reduce the electric field, it is here reach maximum polarization PS. When you reduce the polarization, when you reduce the electric field, the polarization is reducing, but it is not coming to zero. It is still some polarization is there. This polarization we are calling remanent polarization. What is that? Remanent polarization, you can say. Okay, remanent polarization. You can write here PR. Remanent or remanent polarization or We can say remnant polarization, or you can say persistent polarization also you can say. That means material having some polarization. Still in the material, in the atom, charges are separated. Even in this axis, what is the electric field on the y-axis? Zero, right? In this place, what is the electric field here?
So zero.
Yeah, in this condition we make the electric field zero, but still some charges are separated. Some charges are separated in a atom. Because of this separation, we are having some polarization. This polarization, what we are calling remanent polarization. Remanent polarization, or remanent means remaining polarization, or persistent polarization. Okay, so to make this polarization zero, along negative side we are applying some electric field. Okay, so negative side we are applying negative, then after certain electric field, so this polarization becoming zero. This polarization becoming zero. This particular here polarization is zero, right? Isn't it? What is the polarization on the x-axis? Zero, right?
Yes,
So,
sir.
so this field, particular field we are calling cohesive field. Cohesive force, or EC is the cohesive field. Cohesive field. Okay, so to make polarization, remnant polarization zero, we are increasing the electric field. Okay, we are changing the electric field. Particular the electric field, the polarization becoming zero. That polarization we are, that field we are calling cohesive field. Cohesive field. So again we are increasing the negative electric field. Again the polarization is increasing, but this is reverse direction. Okay, reverse direction increasing. Again it is reaching. Again it is reaching saturation. So when you apply reverse magnet electric field, what happens here? Charges will reverse. Okay, suppose you have applied positive electric field, charges are induced like this. Okay, so when you apply negative electric field, what happens? Charges will reverse. Here plus charges, here minus charges, like that. But still here also charges will separate. Here it is reaching saturation. After that, when you decrease again electric field, it is polarization decreasing. Still after certain electric field zero also, here on the y-axis electric field is zero in this case, but polarization is not equal to zero. This particular polarization we are calling again remanent polarization. To make this polarization zero, again we are applying positive electric field. So this is like this, it is increasing. So at this x-axis, electric field is not equal to zero, but polarization is zero. This field we are calling cohesive field. Cohesive field. After that, again we are increasing, and again it is reaching saturation. Okay. So this loop we are calling hysteresis loop, or PE loop. Okay. So tomorrow we will discuss remaining part. Okay. Is it clear today class?